Hello, everybody. Welcome to the OpenUSD Insiders live stream. Super exciting. As you can see, we have a full suite of guests here, famous people from inside of NVIDIA here to explain some of the amazingness that was shared at CES. So we're going to go over many of the announcements really briefly. And then we're going to obviously open up the live Q&A. So feel free to ask your questions along the way. Since we're going to be touching on different announcements, we may not be able to go into a deep dive into everything. However, that's what we have Discord and the forums and our other live streams and study groups for. But here we want to give you a good overview of some of the main things probably everyone should take away from what Jensen and the team shared at CES. Okay, so again, we're going to be focusing on the physical AI highlights. And let's start with let's do a quick round of introductions. Everyone should know Ashley over here. Hey, Ashley.
Hi, hello. I'm reporting from this warehouse. Just kidding. I'm actually reporting from, hold on, headquarters. Oh, don't look at this person. He's not in the live stream.
Awesome. Okay, and Ashley, you'll be covering a little bit later when we talk about Kit.
Yes, I'm going to go over the Kit 106.5 release notes.
Okay, perfect. Okay, and then to my other side, Panjali, how are you doing?
I'm doing good. Good to be here. Thank you for inviting me.
Of course. And what's your role at NVIDIA?
I'm product marketing manager for NVIDIA Cosmos and NVIDIA Edify, really exciting generative AI tools and platforms.
Awesome. Yeah. All right, so we're going to circle back to you because you're going to be our first guest to kind of present what was one of the major announcements in a long time, actually, in NVIDIA, which is Cosmos. So very exciting. Okay, moving right along, Jen Baruki, a veteran of the live streams and a good friend. How you doing, Jen?
I'm doing good. Could use some more sleep, but that's what I get for not drinking coffee.
I knew you were going to mention coffee somewhere in there. I was waiting for it. All right, and you're going to be covering. Tell me what you're covering. You're covering AVP, right?
Yeah. A little bit about AVP, and especially what's to come with AVP coming GTC.
Awesome. All right. For people who don't know, Apple Vision Pro is AVP. And then we have next to you, we have Maddie. Hey, Maddie.
Hello. It's been a while, but good to be back on here. I'm representing USD, Learn OpenUSD, some of my favorite topics.
Awesome. And Maddie will be talking about some of the latest releases on the Learning OpenUSD courses, the level 200, so to speak. So really excited to share more information about that. And next to you, I see Katie. How you doing, Katie?
Hi, Edmar. Hello, everyone. I am the product marketing manager for autonomous vehicle simulation at NVIDIA. I'm reporting live from cold and snowy Detroit today.
Very appropriate for what you'll be discussing. Very exciting automotive coming out of CES. So we'll tune into your section in just a few minutes. And the third row we've got here, starting with Mike Geyer. How you doing, Mike?
Yeah, good. Hey, Edmar. How's it going? How's it going, everybody?
Good. Why don't you tell me a little bit about what you do here and what you'll be touching on today?
Yeah, excellent. Hey, I'm one of the product managers in the Omniverse group, and we're going to talk about the mega announcements that you saw at CES. Some pretty exciting stuff. Looking forward to it.
Very exciting. So Mike we're coming up in just a couple minutes. And last but not least, our good friend Max. Hey, Max.
Hey, everybody. Hey, Edmar. Great to be here again, back on the live stream. I'm product manager for all the spatial stuff that we do on the Omniverse team, and I'll be alongside Jen here talking about our work that we announced for Apple Vision Pro.
Super exciting. Okay, thank you all for joining us. I wanted to make sure everyone kind of knows who's who here so that you can start engaging in the chat right away. Just call out the person you like. And speaking of which, thank you all for watching. Welcome all the people from LinkedIn, from X, from YouTube. And feel free to post what you're working on. If you're working anything with OpenUSD or Omniverse or any of the topics we're talking about, feel free to post your projects in the chat. It really helps other people connect with each other in the community. Maybe there's someone there who wants to work with you. Let us know where you're watching from. With that being said, let's get the party kind of started with showing a quick overview video. It's about 2 minutes long of kind of all the announcement kind of wrapped into one nice little sizzle reel. So let's start with this, and then we'll come right back and we're going to dive right into Cosmos. So here we go. Here's what we spoke about last week at CES. Goosebumps. I just love that video. I could watch that over and over again. I have watched that many times.
Dude,
so
shout out to the creative team. They kill it every time. You know, they get like dozens and dozens and dozens of renders from all over the company and like compile it into this massive sizzle reel. It's like, it's so impressive. I'm always
incredible work, and showing off the work of our partners too. Really amazing work from people around the world. Okay, so now you got a kind of a look, in case you missed CES with some of the stuff we showed off. Let's dive right into talking about some of the main topics, starting with probably the biggest piece of news out of CES was Cosmos and World Foundation Model. So let's talk a little bit about what that is with Pranjali.
Yep, I'm super excited. First of all, that video just pumps me up. We see everyone doing amazing thing with physical AI and how differently we perceive physical AI and how hard it is to develop. I think that's where Cosmos comes in. So physical AI, this is a belief that if we want to excel in physical AI, we need to train these physical AI models like we learn from real world, like we act in the real world. So to ensure that they perceive, understand like humans do, and then can perform complex actions in any edge case scenario or any environment. It is really, really, really difficult to do, and I cannot emphasize it enough until CES when Cosmos released. And before I dive deep into it, I think Johnson is a better person to explain it himself. So, Edmar, can you play the video?
Yeah. Okay. Let's watch this.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance, even across multi-sensor views. Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
Amazing. I love watching that video. I've seen that more than 100 times for sure. I'm gonna dive deep into Cosmos, not so deep, but briefly cover what Cosmos is and how you can start using Cosmos today. But I'm gonna do that while I walk you through the steps to access some of the tools and models that Cosmos platform has. I'm gonna share my screen. This is my first time here on the live stream, so bear with me.
You're doing great, and this is
You're
super
pro
exciting.
already. You're gonna replace Edmar. Don't worry.
It seems
Just
like this is also a very okay. Right now, the screen we see, Pranjali, is the StreamYard screen. So I'm not
okay. Sure. So let's move to the main window. This is what NVIDIA Cosmos is. NVIDIA Cosmos is a platform to develop world foundation models for physical AI. So what it means that you can create realistic, physics-aware future states as videos using text, image, or video as input through Cosmos World Foundation models. And if you want to customize that, then the Cosmos platform also has tools that let you tokenize data, that let you curate data so that you can go ahead and fine tune, and you can use some of the frameworks that Cosmos has to fine tune that model. As I said, it's a World Foundation model platform, which has tokenizer, guardrails, data processing and curation pipelines, and some of the frameworks that help you train and fine tune. I'm right now on an NVIDIA Cosmos main website, which is nvidia.com AI Cosmos. So if I'm a developer who's looking at developing such World Foundation model or access World Foundation model and fine tune it for a downstream physical AI application, I can go ahead and start developing. When I click this start developing, I go on this developer focus page. So what it does, it gets you into this kind of overview of what these models are, what these tools are, and as I think the video rightfully captured, there are two types of models here: autoregressive model and diffusion model. There is no one model is better than other kind of scenario. It totally depends on what you want to use for your requirements. So we have autoregressive models and diffusion models openly available on NGC, Hugging Face. You can also try a preview NIM. What is a preview NIM? I can click on that link. I just went to the diffusion model list, clicked on the page. This is a preview NIM. I can go ahead and maybe add a prompt of what I want the world state to be, or the world state video to be, and it will generate me a video here. This is what you can default. You can change the prompt and you can generate whatever you want. This is a preview NIM. It means you can play with it. You can generate and see how the model is generating these world states. You can also go and start downloading these models from either Hugging Face, which is an NVIDIA collection of bunch of diffusion and autoregressive models. This is great. This is open for you all. You can just go ahead and start downloading and using either NEMO framework that comes with Cosmos platform, or you can use any preferred framework to fine tune these models, or you can use PyTorch to fine tune these model and run for your use cases. It's also available on NGC, which is NVIDIA's GPU cloud. So you can also access it on NVIDIA NGC if you're already part of NVIDIA developer community and have access to NGC. There are a bunch of models with different parameters, different sizes, and different capabilities. So when you go to these collections, please explore. We also are releasing some fine-tuned samples because the idea is to accelerate physical AI for autonomous vehicles, for robotics, for humanoids. So we continue to fine-tune these models with very specific data sets on navigation, on autonomous driving, on driving data, so that we have more focused and more fine-tuned models. There are a bunch of starter kits available depending on the use case that you want to develop. I think Jensen covered in the talk video that you can use Cosmos with Omniverse, because Omniverse is where you are creating all the 3D environments. You can use those generations that you've done on Omniverse, use those 3D structures to control the generations from Cosmos. You can feed those 3D environments from Omniverse as input and generate controlled world states as videos from Cosmos. So together, both of them will revolutionize physical AI, will accelerate physical AI development. You can also use, as I said, GitHub library for Cosmos to find some fine-tuning codes and guides for customizing both diffusion and both autoregressive model. Everything here is on the Getting Started page for developers. And if you want to learn more about what are the use cases, as Jensen talked in his video, some of the use cases are here. You can also use a video processing pipeline, the NEMO curator pipeline, to really do a video search, curated data, and then tag those videos and create a video search that is focused on your use case and follows the patterns. As I talked about, you can do a controllable 3D to real synthetic data using Omniverse and Cosmos, feed your 3D environment into Cosmos, and generate a world state as video. a lot of robotics and autonomous vehicles need some policies for their physical machines to follow. So those physical models can also be trained by the synthetic data that is being generated by Cosmos. You can also fine tune on your physical policy model requirements, and the model will adapt to that, and it will accelerate your policy model development. Therefore, it will accelerate deployment of your physical AI models. There's a lot to uncover here. Go ahead, explore all the assets, all the web pages here. There are some bunch of really good information. There was a bunch of really good information there in press, in blogs. Again, Cosmos is a world foundation model development platform, which has a world foundation models and tools that help you customize those models. I hope you enjoy that. Let me know if you have any questions.
Well, that's amazing. We actually have one question in the chat already. A lot of excitement over Cosmos. Well, first one's from me, actually. So for support, where do you recommend people go to? Not GitHub, probably the forums?
Yeah, probably the forums. And I would say that's a great question, because they can go first try the NIMs, which is on API catalog. And if they want to download them and run inference, they can use forums to ask those questions. And if they have more requirements from an enterprise side, they can always reach out to NVIDIA AI Enterprise for an extended support.
Okay, great. And we have this great question, which is a good kind of advertisement for what's coming up later on this month. Omniverse ambassador, actually, Pekka Varas, hey Pekka, asking if we could show off Omniverse and Cosmos workflow. And we are actually going to do a deep dive on this in a couple of weeks. We're going to be sharing that link a little later in the live stream, but end of January, we're going to do a deep dive. But is there anything else you want to address on this?
Yeah, I wish I could show you, but we are building for the live stream. So I could definitely run it. It's going to take more time on my side, but let me hang in here. And if I find it out, then I'll drop something in chat or share it on my screen.
Perfect. That's a good question. And let me see one more question here. Because obviously, this is incredibly impactful for robotics and autonomous vehicles. But we also have a question here. Do you envision using Cosmos for other applications in industrial design?
No, because we are literally focused on a lot of, I'm just going to take a step back and talk about why Cosmos is important, because it's the data strategy. We are curating this data just for physical AI to ensure that robotics and autonomous vehicles data is captured. These models are trained on those kind of data like hand gestures or navigation or object manipulation, those kind of stuff, which is going to be hard. You can always pick up a world foundation model and fine tune using your own data set, but that's not the purpose for Cosmos. So it's going to be hard.
Okay, that's great. Thank you so much. Great question too. So thanks for asking that. All right, so Pranjali, we're going to move over. We're going to continue talking about robotics with Mega and Mike Geyer. Mike actually has a meeting shortly after his presentation, so he won't be able to stick around too much longer. So I want to make sure we get him in as his time is hot. All right, so tell us what is Mega? What's a reference workflow for robot fleet simulation?
Mega's huge. Hey, thanks, Edmar. Great stuff on Cosmos, man. That's just it's amazing to see that. It's so exciting to think about where that's going to be in 6, 12, 18 months. So yeah, hey, again, Mike Geyer, one of the product managers in Omniverse, and lucky enough to work on all this amazing stuff that we saw in the video earlier. And this project we're calling Mega. So at CES, you would have seen the presentation Jensen did about the Mega project with Keon and Accenture. And I'm just going to talk really quickly about who it's for, what it is, and why we're doing it. So who it's for is really right now for a robotics test engineer. What it is, Mega is a blueprint. So it's going to be another one of our technology recipes that uniquely leverages some of the NVIDIA foundational technologies and could be remixed by anyone in this live cast or any one of our partners to their own purposes. Why we're building Mega is we have problems on our own of testing robot fleets. So our robotics team has never really been able to test more than 1 or 2 robots at a time. And Mega is going to help us test an entire fleet. It's going to help you and all of our developer partners test entire mixed fleets of autonomous agents as those become more of a thing in industrial worlds. So kind of the background of how we start to think and talk about Mega is this next wave of AI, right? So right now we're all fully immersed, super excited, and surfing kind of the LLM and the agentic AI wave, and it's captured everybody's imagination, and just the things that are happening are so incredible, and everybody's kind of wondering, how far does this go? Well, we know that where this continues, kind of the next phase of the agentic AI, is physical AI, is AI that not only learns from a data set of text in a database, but learns from the physical environment that's based on physics. If you think about a warehouse or a factory or a really large complex physical system, these things are throwing off terabytes of really crucial data every single day. And all that data can be used to train the autonomous agents, the robots and the augmented humans and machines to do their job better, to be more efficient, to have better paths, to work together better, to do all the things that are necessary to coordinate thousands of workers, tens of thousands of machines, tens of thousands of sensors and PLCs. This is the wave of physical AI. And what we're so excited about with Mega is that Mega makes it possible to start testing virtually in your digital twin that interaction between all of these different agents. And so there's kind of 4 big chunks to the blueprint. The first is really the facility and the fleet manager. So this is kind of think about this like the game plan or the orchestration level, where if I've got a fleet of robots that are moving around a warehouse, this is how they know what they're trying to accomplish in a given day, week, or month, based on the business requirements of what kind of deliveries are coming into that facility, where do they need to be stored, how do they need to be broken apart, how do they need to be put back together into palletized or containerized segments, and then shipped out. That facility or fleet manager tells the robots what to do. The next segment is really the robot brains or the robot AI models. And this is how the robot reasons before it acts. This is about the decision tree, the logic, and really the AI that's in the robot. But we're thinking about robots in a bigger context than just maybe an AMR manipulator, a humanoid. A robot could be a camera. A robot could be the entire facility, anything that's able to perceive, reason, and act. When that robot then needs to act, control signals are sent into the world simulator. The world simulator is a kit-based app. You could build your own. You could use our blueprints. But this is comprised of that digital twin that's built in your virtual facility integration workflow. Using USD, could be an Omniverse, could come from other places, but really the virtual model of the facility in which you want to test this fleet of robots, make sure they're finding the right path, interacting with each other, that you've got the layout correct. And then the perception aspect is Sensor RTX. And Sensor RTX is where we disaggregated the compute, the big bottleneck that's been preventing us from being able to test more than 1 or 2 robots, because those robots have 6, 8 sensors on them. They're LiDARs and cameras, and those sensors are incredibly compute intensive. And so what we've done with Sensor RTX is now the simulation of those sensors is done in the cloud in a distributed fashion. So each sensor can have its own GPU. It can run as fast as it needs to. And we're not limited in the scale of testing that we can do by the compute that's available. And so then the Sensor RTX stack feeds the perception data back to the robot. It says, okay, there's nothing in my way. I'm going to progress to the next step, triggers that in the world simulator. So this is really where Accenture and Kion are doing some groundbreaking work in being able to test the robot fleets in their facilities. And so, as I said, Mega is the blueprint, and it's built for simulating robot fleets in large-scale industrial twins, digital twins. Accenture, one of our great partners, is working with Kion, who's a leading supply chain supplier, to create what you see here, which is that perception stack, kind of the various eyes of each of these robots as they move about this massive facility, and the small windows you see around each of them, that's what they see. And that's what they see rendered through sensor RTX. And so now we can do the testing in this massive scale. I think that's kind of the main thing I wanted to get across. So if you're working in robotics, you're working in warehouse, factory, and think that this is something interesting that you might be able to use in your development projects, definitely reach out and let us know. We're interested to learn. This is going to be a project you continue to see us do more with. So with that, I'm going to pause my sharing. And thank you so much, Edmar, for having me here today. It's great to be with you.
Mike, thank you so much. This seems to be one of those things that once adopted, people will realize, how did we ever do it before? It seems like such a huge time saver and money saver. It's just win, win, win all around. Thanks for going over all that. I really appreciate it. So everyone, say wave goodbye to Mike. He's got to head out. So thanks, Mike.
Bye, Mike. Based on Mike's...
hey, take care, everybody. Cheers.
Bye, Mike. Based on his definition of what a robot is, that it can perceive and act, all of us could be robots.
Well, I'm not going to argue with you. You may
Max
be,
looking around
Max,
like,
Max
oh,
is very
shoot,
robotic.
They caught me.
Well, speaking of robots, we actually have a pretty cool, let me see if I can present my screen really quick before Katie's going to talk a little bit about Sensor RTX. Akil, who is going to join us, he's a little bit under the weather today, so I'm going to do my best to do my best Akil presentation. I won't do nearly as good as him, but basically we've got some great updates imminent right now regarding Isaac Sim and Isaac Lab. For those of you in the community, you're already very well aware, hopefully, about our Isaac Sim and Isaac Lab study group, which actually happens later on today on Discord in the community room channel. So we invite you, if you want to learn more about Isaac Sim and Isaac Lab. Amazing discussion there. I think last week we hung out for 2 hours. Really, really fantastic. So anyway, we have Isaac Sim 4.5, Isaac Lab 2.0. Lots of great features, as you can see on the screen here. Improved physics simulation and modeling, simplified installation process on the Isaac Lab side. These tools really go hand in hand with each other, one for simulation, one for kind of physical. Again, the Isaac Sim and Isaac Lab study group meets weekly on Wednesdays on the Discord server. That's led by Omniverse Ambassador Scott Dempsey, who I just saw in the chat a few minutes ago. So it's a great place to come and hang out and learn about these two great applications. We have also a Groot update, which I think is here. So this was also announced during. Oh, it's not sharing my tab. Let me see. Share this tab instead. There you go. We'll post this link in the chat. Let me see. I'll do it right now before I forget. But this is we just announced Groot last week at. There you go. There's the blog in the chat. We just announced this last week. Isaac Group Blueprint to accelerate humanoid robotics development. Humanoids were all over the place at CES. Probably one of the most fun things. I know Ashley. We had a fun seeing some robots on the floor last conference we were at. They're evolving so quickly, and I think one of the most exciting things that to me in what Jensen shared at CES was NVIDIA's goal of empowering developers worldwide. At all different levels, so making this development for robotics as accessible as possible to everybody. And Groot is one of those things that helps do that. So I hope people dive into this. We'll share the blog. If you have any questions, we have our support forum and we have the Discord server. But with us, we also have Katie, who's going to talk about something on a related note. Katie, so you have also been very busy. As of the rest of the team, but you are going to tell us a little bit more about Sensor RTX and the AV Sim Blueprint, right? So you're in Detroit, as you mentioned before, so the car capital of the world. So tell us how all this relates to each other.
Okay, of course. And I wanted to apologize ahead of time. I am battling a post-CES cold, so apologies for any sniffles or coughs that may.
Thanks for joining us.
But is my
yes, yep, we all see your screen.
Okay, awesome. So Mike mentioned the Sensor RTX APIs briefly in his mega overview, but really the APIs, we envision them as a tool for any sort of physical AI development. I think I saw someone in the comments say that Sensor RTX plus Cosmos would be a killer app for synthetic data generation, and you're definitely on the right track. So we designed the Sensor RTX APIs to address the data challenge in physical AI development, because both robots and autonomous vehicles need to be able to handle any type of scenario they would encounter in the real world. However, many of those scenarios are difficult to encounter in data collection or dangerous. You know, if it's a pedestrian crossing the street at night, or a rare weather condition, these are all situations the machine should be able to handle, but may not necessarily make sense to go out and collect in the real world. So we use simulation. However, the simulation must be as close to the real world as possible in order for the machine to transfer from simulation to the real world. So this has been a long-standing challenge to kind of achieve the fidelity necessary for training and validation, while also at the scale needed for autonomous vehicles and robots. So with the Sensor RTX API, it works by taking in USD data and rendering out camera, LiDAR, radar, and any other sort of sensor necessary for autonomy data entirely in an entirely physically accurate way. The API integrates into existing developer workflows via our blueprints. So Mike showed the Mega blueprint. I'll show another blueprint in a couple of slides. So developers can access these capabilities without having to entirely rebuild their infrastructure. So as I mentioned, the APIs render both camera and non-visual sensor data. In addition to that, they include all of the ground truth labels with this data. So another challenge with training data is having to annotate every single object in a scene. And we need those annotations to be able to measure the performance of a robot or autonomous vehicle's perception. So we need to know when they say that's a car going through an intersection, what they saw was actually a car. Now, manually annotating all of these objects is incredibly labor intensive. So by pre-labeling this data with Sensor RTX, we can bypass a lot of the time that traditionally has been spent in annotating this data. So all of this combines to enable us to provide a robust simulation environment that mirrors the real world, so we can comprehensively test, train, and validate autonomous machines. So these APIs integrate into existing workflows via our blueprints. So we have the Mega blueprint for manufacturing, and we also announced at CES our blueprint for autonomous vehicle simulation. The blueprint includes both the Sensor RTX APIs for the rendered sensor data, in addition to our AV Sim enhancement service, which provides the animation and behaviors that turns the rendered sensor data into a full-blown simulation. On top of that, you can plug in additional services like neural reconstruction or a Cosmos World Foundation model to then scale out scenarios for testing. But developers can use their own simulation engine, their own storage. You can have complete ownership over your own data. So it's really a customizable solution to work with whatever pipeline you are already using. So the APIs are currently in early access, and our early access partners for AV simulation specifically are Carla, Fortelix, MathWorks, and MITRE. So at CES, Fortelix demonstrated some of the work they've been doing already with Sensor RTX. For those of you who may not be as familiar with them, Fortelix provides an AV development toolchain where companies developing autonomous vehicles can evaluate the performance of their stack on their toolchain, kind of measure performance and accuracy. Sorry if you hear my dog barking in the background.
Never apologize for pets. You're welcome.
So with the Fortelix toolchain, you can kind of pinpoint weaknesses in the stack and then generate new scenarios for testing to address those weaknesses and kind of evaluate the stack as it improves and iterate on development. Okay, Edmar, could you play the video?
Yes, we'll do that.
That
And I can see
dog
this.
sounds super cute, by the way.
I think they're excited for the video, is what I think.
He's a 15-pound mini Australian Shepherd.
Love it.
Very territorial.
Okay, here we go.
Okay. So this is a sample look at Fortelix's tool chain. So as you can see, this is a real world drive from a Neuro autonomous vehicle driving, I think it's San Jose, or actually, sorry, this is Mountain View area. So the data is being uploaded into the Fortelix tool chain. They're evaluating the vehicle's performance, and then it is run through, or it's the coverage of the stack is measured. And as you can see, it's not performing super well. There was a lot of yellow on the screen. So the tool chain then generates specific scenarios to target these low coverage areas. And these scenarios are generated in object simulation, so object level simulation. So incredibly basic, kind of just a map and boxes. That object level simulation is then fed through the sensor RTX APIs, and we render out the camera, radar, and LiDAR data. Then on top of this, we can generate new scenarios, new lighting conditions, new weather conditions, data that would not show up at the object level, but is necessary to train the vehicle. And so the stack is then run through all of these tests in simulation. We reevaluate the stack, and we see improvement. So this is just a sample workflow of how a company is plugging in the APIs to really enhance what they're already working with.
That's amazing. That is so cool. Thank you for walking us through that. And for anyone out there who's watching, again, feel free to post your questions, your comments, if you need help with finding resources. But thank you, Katie. I really appreciate that that overview.
Say hi to your dog for us.
Yes, give a good treat.
Yeah, he said his many hellos.
All right, awesome. Well, actually, speaking of pets, my fellow pet lover here, Ashley, you are going to talk about. She's got like 50.
No,
yeah.
I don't. Don't spread that misinformation. My landlord will come at you.
So you're going to talk about Kit, right? There's a big Kit update. Kit 106.5. Kit is the SDK that kind of helps people to build applications. But tell everyone who might not be familiar with Kit, why don't you start by just describing what it is, and better than I just did, and then what's coming.
Yeah, so our Kit SDK is what enables developers to create their own Kit application for Omniverse. So if you hear Omniverse, you hear Kit. Kit is the SDK, and Omniverse is the development platform for OpenUSD and digital twins and robotics, all that good stuff. And so for almost a year now, we've been working with the Kit 106, which is a developer-focused platform, enables developers to make their own custom applications. And if you missed your USD Composer, we have USD Composer templates, we have Kit-based templates, we have USD Viewer templates, so all these different templates that allow developers and creators to make their own application how they see fit for their workflow. And so at CES, we released Kit 106.5. It's not a major update, but there are some really cool things that I didn't want people to miss out on. So I pulled those out of our release notes, and I'm going to go over a few of those today.
Awesome. You want me to share your screen?
Yes, please.
And also, just a quick side note, we have a couple good questions for Katie. We're going to circle back to those in a minute, so hang tight. We'll get to those questions. We'll first review Kit. Okay, go ahead.
Yeah, cool. This is not too long. Like I said, there's not many, but some really cool ones. So I'm lead tech marketing engineer, if anyone is not familiar with me, and I work in Omniverse and Simulations platform. So primarily what my job entails is helping to get all this cool internal information about the Omniverse platform out to the technical developers through our marketing content. And so let's just get right in. The first thing I wanted to call out here is the improved UX for creating a new project. Now, I'll be honest with you, I had not used this before, and I was like, why would anyone want to do this? Like, what's the point of this? Why is it useful? Because it was like the first thing in the release notes, so obviously it was really important. So I talked to some of the project managers here, and they said that the reason this is so useful is because from GitHub, you can, just clone the repository again to start a new project. If you already have Kit on your system, it'll just use that. But if you're in NGC and Kit is a download, so you can go here and start a new project without needing to go back to NGC to download it again. So it's a really useful workflow when working within your cloud development. He also noted that the feature branches of NGC and GitHub are the same, but the only way to get to the production branch as an OV enterprise customer is to download it again from NGC. So this is a really big enterprise workflow to use new project, and they've just made that easier for everyone to do. Next, that I thought was really great to call out was the added options for prims in your stage. So, when you go over to your stage and you right click on your prims, you can now show or hide your inactive prims or show or hide your abstract prims. So it just cleans up your stage a little bit more as you're working through with really large data sets. And of course, always improving the developer workflow when you're working in developer mode, and that is improved Markdown support for the extensions window. So I did this myself, and I was like, oh, this is amazing, because when you are launching in developer mode, which, your repo.bat launch -d, if you didn't know that, it's developer mode. That's how you can go find the extensions manager and find all of these new extensions that you can add to your own Kit application. So if you're like, how do I find new extensions and see what I want to add to my custom workflow, going in there is helpful. And they added this new filter for featured. So you see @featured right when you open the extensions manager, and it calls out all of the featured extensions that we want you to check out. And then we've improved the Markdown support for the extensions overview. So that right-hand side of the extensions manager, where it gives the overview and shows you what the Kit extension does, that has been improved so it's easier to read. So nice and pretty. And then USDZ support. So if you see my background here, I got my Frog Manager or Manager Frog, and everything in here is actually USDZ that I pulled from TurboSquid. So USDZ is just like a really great way to export your assets to share them more easily. Think of it like it's like a zipped, compressed version of the USD file. And so in the assets exporter, now this is not on by default when you create a Kit-based application. You have to make it a dependency or enable the extension in the extensions manager. It's asset exporter. So you turn on that extension, and it exposes this file or this menu option for export. So you go to File, Export, and now you can export as a USDZ. Like, so easy, amazing, we love it. And then you can create your own Manager Frog warehouse with ease. And then Manager Frog makes an appearance again. We have this really awesome feature that I was like, man, this is like so buried down the release notes. But if you're like me and you like to try new stuff and you're okay with things breaking because it's in preview and you just want to be that fun little guinea pig, we've exposed the real-time 2.0 RTX preview. So you go into your preferences and you go to rendering, and there is the RTX real-time 2.0. It's a preview, right? So it's just a way for you to check out what's going to be coming in the future. And this is eventually going to replace our current real-time mode. Now, you might notice that in the left-hand side, I've got the original one, and on the right-hand side, I have the new one. There are small improvements to the viewport, so you're not going to see a drastic change. It's a little bit sharper on Manager Frog's textured knitted fabric, but the most important part is actually the render settings. So in the real-time 2.0, in the preview mode, there are more streamlined ways that you can edit your viewport and your render settings. So you're just making things a little bit faster. You don't have to know as much about the rendering settings. You don't have to be a Richard Yarlett and have, a million years of experience as a tech artist to understand what these are. And it just makes it a little bit easier for you to manage your scene and manage your viewport. So check that out. It's in preferences. You have to enable it, restart your Kit application, and then it'll be available for you to switch over to and check out.
Amazing.
I think I just got a couple. I think there's like this is our last one, and then I'm going to expose the rest of the release notes. And then the last one for all of our creatives out there that are working with materials and MDLs, there is the improved node list. So they've been grouped a little bit better that make more sense. And so you can check out all the new groupings and how the MDL shaders are put together in the material graph. And then if you want to see the full release notes, there's been lots of little minor changes and fixes. You can go to the docs. I've exposed the URL there, and it'll just give you all of the small changes that we made to the 106.5. And then if you want to get started with 106.5, easiest way to do that is just go to our NVIDIA Omniverse GitHub, go to Kit App Template, and just clone the repository. My recommended workflow is clone the repository, make your own branch so that every time there is a Kit 106 release, you can just switch over to the main branch, pull that origin, and then create a new branch with your new release so you're not messing up your old workflow just in case of anything's missing. And then Manager Frog is always watching, making sure that you are on point, I guess.
Amazing.
And there you go, done. Kit 106 in your hands. Go do it.
That was fantastic overview. Thank you so much, Ashley.
Woohoo!
Okay, super exciting stuff. And I posted the link in the chat, but Michael Wagner is a big fan of Kit, as he shared earlier. He's got a great LinkedIn post where he integrated Flux and Trellis in Omniverse. So I put a post to his link and his LinkedIn post. You should follow him on LinkedIn. He has great blogs and articles. Very, very helpful at sharing information. So thank you, Michael, for all your great evangelism of OpenUSD. I wanted to circle back to Katie. I think we had a good question earlier before, and now obviously anyone can ask questions along the way. We'll try to circle back to all of them. Okay, so let me see. Which is the one that was it? Was it this one?
Yes.
Okay.
I can answer that one. Yes, so that's exactly the idea behind it. Is you can take a real world drive and render out all of the sensor data from that drive in simulation. And then from there, you can generate entirely new scenarios using generative AI or Cosmos. And you can vary lighting, weather, increase the complexity of the scenario. So you can scale from tens of driving scenarios to hundreds of thousands to accelerate the testing pipeline.
Awesome. Okay, great. And we have a follow-up question. This is from Scott Dempsey, Omniverse Ambassador.
Yes. So Sensor RTX can be linked to manufacturing configurations. So as Mike showed in the Mega Blueprint, that would be kind of the reference workflow for those applications.
Okay, amazing. All right, great. Thank you so much for circling back to those. All right, so I'm very excited for these next couple of guests, Max and Jen, talking about AVP, which always sounds, I don't know, sounds very...
Where I'm from, that's Alien versus Predator.
Yes. I think of that every time, too. I'm so glad I'm not the only one.
Best game growing up. Probably a little too... I probably was not old enough to be playing that game, but it was great.
I'll shoot an email to your parents. But everyone else, it's Aliens versus it's Apple Vision Pro.
Got you.
I'm in trouble with my parents. All right, so Apple Vision Pro. So tell us what was the big news out of CES for Apple Vision Pro?
Yeah, so last GTC we showed a proof of concept of streaming Omniverse into an application on the Apple Vision Pro. And we ran a small, here, I'll play this video. I'll just talk over it here.
And maybe, Max, we can hear you, but maybe talk a little louder.
Or if you go into settings, I think you can turn your mic volume like as high as it can go.
Let me do that.
And I can blab away to make sure that no one's noticing you doing that.
Is that better?
I'm a good yapper.
Yeah, much
better. Is that better?
Yes.
Okay.
There we go.
Okay. Great. So last GTC, we showed essentially this video of something our friends at Katana did, who are an Omniverse developer, streaming into the Vision Pro. And the really awesome thing about this is that the Kit application was actually running from GDN, which is our graphics delivery network, up in the cloud. And so the users of this device, they had no workstation near them. They had no idea that the application was using Omniverse. It just felt like a native Vision Pro application, except they saw a data set of complexity and size and detail that the device could never render on device. And that's saying a lot, because the Vision Pro is a very powerful device that can really do a heavy lift when it comes to 3D rendering. So we thought this was pretty cool. We did some early access and some continued development over the summer, and then we officially released this at CES. And so now all the tooling for folks to go and start to build these applications is now available. And so kind of give you a broad overview of what that tooling kind of looks like. It's kind of three pieces. Omniverse is our back end that's opening our USD data, manipulating our USD data, and serving up a render. Our client, our CloudXR client framework that we have is a Swift framework for Apple Vision Pro that users will build, and that will connect to that Omniverse server. And then CloudXR is the piece in between there that is the protocol stack that we use to send all that information, both from the client. We're going to send your head pose inputs back to the server, and then the server is going to give us back lots of lovely pixels. So in this way, we start to sort of describe these applications as hybrid applications. And we think this is a really interesting first step into the future of spatial applications and XR experiences, where we'll take the Apple Vision Pro, but in the future we'll be talking about more headsets. On the Apple Vision Pro, you have an application where a portion of the application is being computed and rendered locally on that device, and then other parts of that application. Sorry, is my volume still really low?
No, you're good.
We can hear you.
Other parts of that application are being rendered off device, and then they're being composited together into a single experience, and sort of they feel like a cohesive application, but the compute is shared. We think this is really cool when you think about how fast AI is coming into this equation, and the ability for people to now build applications where they can scale up the compute to build these super applications that can do incredible workloads that would never be possible on these really tiny devices. And that's really important because as much as I love pretty much every headset that's out there, I think we all agree that battery life could be better, the weight could be better, the heat distribution could be better. And so if we can start to design applications and architect sort of use cases where we're sharing that compute on device and off device, we think those devices are going to be able to keep getting a lot smaller while maintaining the ability to keep those workloads kind of at the sort of limitless possibilities that we want them to keep going. So a couple more things we showed off at CES. We had some more partners bring some demos. Our friends at Katana continue to keep building some incredible car configurators that they bring to the Vision Pro. And then our friends at InnoActive, they've managed to get this technology running off of AWS and over 5G, and so they're showing a demo here where the network implications are kind of a little chaotic, but because of some of the secret sauce that we have in our reprojection algorithms that come with that framework, we do a lot to account for latency that sort of is going to always exist between the client and the server.
And this connects with the USD-Z exporter from Kit 1065.
Yeah, pretty much everything that folks have been talking about kind of feeds into this. If it's a USD that you can render inside RTX in Kit, then you have a path for getting that render into an application on the Vision Pro. And then what's also unique is we're not just sending pixels and poses back and forth. We have a data channel that exists between Kit and the client. And we allow developers to leverage that data channel for a number of different use cases. You can say, put a message in from a piece of Swift UI. So if you want to change the color of the car, you can have all that UI and functionality native and local to the device. And then we send a message up to Kit, and we use some Python on Kit to update the USD variant or rotate the object or scale the object or anything like that. And then we talked kind of briefly about it in the Groot portion, but the Groot team is using this stack to do their teleoperation work. And so just what I talked about, they have Isaac, which is a Kit application running in the background. They have a front-end client for Vision Pro, and then they're sending hand poses and head poses back over that data channel into Isaac, and then Isaac is translating all that data into manipulation for the robot, which is super, super cool.
Amazing. What a great workflow. Thank you, Max.
Yeah.
That's great.
And then we have a ton of interesting things, exciting things planned for 2025. We have GTC coming up, and so I'll kick it over to Jen. Jen's going to be running some amazing labs for us at GTC. Maybe, Jen, you could give us a quick preview of what types of developers we're hoping to see at GTC.
Of course, but I can't really show anything because that's still top secret. And don't give me all the credit. You're still going to be there, with me as well. I'm not going to be the only one running it. Maybe this time at GTC, I won't be stuck behind a monitor the whole time, but we'll see. But there's going to be some pretty awesome courses where we're going to be kind of a little bit splitting them up. So if you attended the one at SIGGRAPH, we focused a little bit on the client side and a little bit on the server side. So we did a little bit of both. Whereas what you can look forward to is coming to this GTC is we're going to be kind of taking it a step back and splitting it into two, where we're going to do one course that's focusing more so on the client side interactions, and then another one that's going to be focusing more so on the server side. So what can you expect between the client and the server? Well, the client's going to be mostly done in Swift, so you're going to see a little bit more on how we're creating those interactions on the client side to interact with the server, and how you can set up the UI to basically send those communication messages over. Whereas on the server side, that's going to be a lot of mostly done in Python, and how we can then consume those client messages that get handled. Now, the interesting part is if you're coming from the SIGGRAPH and you're like, well, I already taken the one from SIGGRAPH. Should I take both of them? Well, if you're coming from SIGGRAPH, I would recommend you would go on to the Python side of things, because that one is going to be mostly focused on factory and digital twin related content, whereas the client side one is going to be more focused on the configurator side of things. So like what you see with Katana and their kind of configurator, we have something very similar, which is our purse configurator, which you might have seen Ashley done. We've also put it into AVP
Trusty
as well.
old purse.
Yeah. So it's kind of, a little bit of a repeat on SIGGRAPH, but we're more heavy, deeper dive on that client side of things, rather than in SIGGRAPH, where we did both Omniverse and the Swift portion of it.
Yeah, I think what we learned from SIGGRAPH was we're pretty unique technology stack in that we're bringing together kind of two large developer ecosystems to create a unified architecture between these servers and these clients. And so if you're coming to us sort of a new Omniverse developer, but you're maybe an experienced Swift developer, we want to get you leveled up on Omniverse faster. Or if the reverse, if you're coming to us, you're an Omniverse developer, but maybe Swift development's a little newer to you, we want to level you up on that a little bit deeper than we did at SIGGRAPH. So yeah.
Awesome.
Thanks,
and
Jen.
GTC I just posted a link in the chat. So GTC is coming up March 17th to 21st. Super exciting. I hope as many of you out there can attend. We'll do everything we can on the community side of things to help support virtually and post updates on Discord, but there really is no replacement for being there in person, meeting the developers, not only from NVIDIA's team, but all of our partners and customers and users all over the world who come to GTC. A great place to learn about sessions, get involved with the labs. It's just really a fantastic, fantastic time. If your work involves any of this, you really should think about going. And so speaking about learning, Maddie, you've been ultimately patient here, and so thank you, because this is such a really important part of everything, right? So we have the Learn OpenUSD course materials, which started out with this 100 series, and now you're about to share the evolution, the next step. So what's going on with Learn OpenUSD?
Yeah, so I'm actually really happy I got to go last. We saw a ton of great content, a lot of great visuals, a lot of interesting technology, from Cosmos to Apple Vision Pro to Mega. And if you paid very close attention, you would see that USD was sprinkled all throughout. And so we've been talking about USD for a few years now. We've talked about it as the HTML of 3D. And I do believe that USD is going to be the underpinning for physical AI for all of these workflows, and we're already seeing it. So for that, we've been building a lot of learning content to get developers up to speed on OpenUSD, and I highly encourage you to jump in on this now. In a few months, you're going to come back and say, hey, why didn't I listen to Maddie? I should have done this earlier, because now I really need this. So like Edmar was saying, we at SIGGRAPH last year, we released these what we call the 100 level courses, the foundation courses on DLI, the Deep Learning Institute. These are all available for free, and they have lectures and exercises for you to get hands-on and start using USD if you haven't already. At CES, we also released these applied concepts now. So these are the first 3 courses in the applied concepts: creating composition arcs, asset structure principles, and developing data exchange pipelines. And so these are building on top of those foundation courses, and really getting into practical use cases and workflows of how do you start assembling your USD data into workflows and pipelines for these things that we've seen for robotics, for synthetic data generation. How do I get my data from other 3D formats, or even from non-3D formats, into USD so that I can leverage them in these workflows, so I can annotate and semantically label my data, my scenes with additional data that's going to help my training. So we're super excited about these. And we're working on the next batch of courses. So more to come.
Amazing.
And they're free.
Yeah, they are
free.
That's great. Yeah, that's true. And so we have on Tuesday, I mentioned earlier, we have the Isaac Sim and Isaac Lab study groups on Discord on Wednesdays. On Tuesdays, Nandu Valal, who's another Omniverse ambassador from the community, he has been hosting a study group that Maddie actually here started on OpenUSD. And that is also a really, really fun time if you want to just casually talk about OpenUSD, some of the challenges, how you overcome them, what's the best way to do things. That study group is just an amazing group of people that just helping each other weekly. So I highly encourage that. It's every Tuesday. We put these up on the event calendar. I'll put the link in the chat. We also have them up on our Discord events section. So if you're a member of the Omniverse Discord server, everyone here watching should be, because it's so awesome. Discord.gg/NVIDIA Omniverse. You'll find categories of different areas, many of which we talked about today. Also, we have a live stream section. You talk about the live streams, and where we list all of our events. This has been amazing. As you could see, a few people from NVIDIA had to leave due to other meetings. So I want to thank everyone for joining us who presented earlier. Pranjali, Mike, Katie, Max, really appreciate their time today. And the great questions and comments that came in on the chat. I want to check really quick, make sure Okay, great. Amelia, our producer, has been working really hard in the background, not only helping produce this, but also helping everybody in the chat. So as she said, I will be at GTC with Amelia. Ashley, you going to be there?
Yeah, I'm teaching a lab on precise 3D conditioning with generative AI.
Amazing. Jen, we know will be there. Maddie?
Yep, I'll be there.
Oh, we're all there. All right. So if you want to hang out with this awesome group of 3 people here, then absolutely come and get in touch with us. We have lots of cool stuff planned for the community as well. I'll be sharing where I'm going for dinner every night. So if you want to join for dinner, you are welcome. It will be a great time. And last but not least, I wanted to also acknowledge some of the great developers in the community that have just been sharing some amazing stories on LinkedIn over the holidays and after CES, sharing their excitement over not only the Jetson or Nano Super, which has just been released, but also on OpenUSD projects. A lot of excitement over Cosmos, Mega, Isaac Sim, Isaac Lab. It just seems like there's a huge momentum right now for robotics, a lot of excitement, and I think that all these great things we've been talking about have been able to really bring in more people to help working on this stuff, solving some of the world's challenges, and we're going to be seeing really cool stuff, I think, from lots of different backgrounds that we wouldn't have seen before without this level of accessibility. So I'm very excited for the future. Any parting words, Ashley or Jen or Matt? Maddie?
I'm just saying I'm just waiting to make my treat dispensing robot. I've been talking about it for 2 years.
You have been talking about it for a long time.
I've just been waiting for all this technology just to make it easier for me.
Well, maybe Jensen has been inspired by your challenge, and that's why he's releasing all this great stuff.
Yes, he's listening to me. He hears me when I show up to HQ, and I'm yapping away all the time.
All right. Well, so actually, it's so cool to have actually the 3 of you on this, because you guys have actually been very involved from day one.
This is the OG. We're missing Wendy. Absolutely. That's it.
On the live streams, on the Learn With Me series, even on Discord, on the forums. You guys have really been such an instrumental part of the community. So I know I agree with everybody here. It's so great to see everybody back. So you'll see, if you're active in the community, this is not time you'll see these folks. We've got great content planned. I know, Ashley, we're planning the next Learn With Me's. So
I'm going to revive it.
Yeah.
Come back to life in some way.
Look at this. Sirens. It's like the
Avengers. Are you trying to kill us? Didn't they all die?
Or just says assemble and we all get on here.
Yeah.
Yeah, Frank, it's so good to see you. I haven't seen you in a while. I'll shoot you a message on Discord, but it's so great to see you here joining us. And thanks for all the new faces. I saw hundreds of people watching today. Thank you so much for joining us. I hope you'll join us every week. You can check out the calendar on our Ed event page. And if you have any questions, need help with anything, you could always shoot me an email. Super easy, edmar@nvidia.com. Otherwise, thank you, and we'll see you later. If you come to Isaac Lab Study Group in a half hour, I'll see you there on Discord. Bye, everybody.
Bye.